This video we're going to be looking at some of the different types of operating systems to kind of put an end to the entire operating system topic. So we're going to be looking at the following different types: distributed, embedded, real-time, multitasking, and multi. So each operating system that is out there will have maybe one or more types that it belongs to. And each operating system has a specific purpose. So, for example, iOS on Apple phones is very specifically designed to work on portable devices such as tablets and phones, whilst macOS is designed to work on desktop. They look, they feel, they work differently. So each operating system has a very specific purpose behind the scenes. So you need to be able to decide, based on any given scenario, what type of operating system would be best suited for it. You're not expected to say which operating system is best. Now, this is kind of a little distinction I want to make before we get really into this unit, that if you're given a scenario, for example, what's the best operating system to use on a mobile device, you wouldn't turn around and say Android. You'd say probably single user multitasking operating system. So you say the types of operating systems which are linked to it, not an actual brand name itself. Let's look at them. The first one's real-time. So real-time operating system is an OS designed specifically for a purpose. Now, this purpose is going to be very specific, and I'll kind of get into that in a second. But the other key part of it is it's going to respond instantly or in a very, very short amount of time. That amount of time is going to be bounded, it's going to be very quick, and it's predictable. So we know it's always going to respond within a certain amount of time. So when we say specific purpose, we don't mean I'm going to use word processing. We're thinking more systems based, such as a safety critical system. Now, real time really does mean real time, and we don't want a situation where I've got a nuclear power station and we've got the operating system which is controlling, say, the cooling rods, whether they go up or down or whatever it happens to be. We don't want that delayed in any way, shape or form, because even a few second delay could be catastrophic. So when we have situations like that, we need to make sure that the operating system responds in a predictable time. This does mean it won't be multitasking. Okay, multitasking operating systems inherently can't respond in a bounded time. If you think back to when we're looking at scheduling, the scheduler will decide when things run, and it could be that even with the best will and intention in the world, if I've got too many processes running, then the delay is going to grow and grow and grow. There's not much we can really do about that kind of basic idea. Ergo, multitask operating systems, real-time operating systems won't have the multitasking feature. They can also be used for ticket sales. We don't want a situation where the same ticket is being sold by two different people at the same time, so we need a way of doing that. Now, what it's not, I said it's not multitasking, and it's not a general purpose operating system. We're not going to be using it for our standard day-to-day basis. Even though a real-time operating system might sound good, in reality, because of scheduling and because of just the way general purpose computers work, it's not actually possible. Now, the next one is embedded operating systems. Now, embedded operating systems are, again, very, very specific, and they're designed for devices where you might not even expect an operating system to be installed on. So it'll run on things such as DVD players, washing machines, and other single-purpose devices. When we say embedded, it's going to be on a device, but it doesn't necessarily mean we're talking about iOS or Android. So we're not talking about those kind of operating systems because they are quite generic still. So they're kind of a mobile version of Windows. It's going to run on very limited resources. So inside a washing machine, you're not going to expect 4 gigabytes of RAM and a 3.6 gigahertz processor. It's not designed and doesn't need that kind of thing. So we'll have a very simple microprocessor. It's going to have a very small amount of RAM to store what program your company selected. So it's going to be very, 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 very specific. The operating system is going to be stored on the ROM of the device, okay, the read-only memory. It doesn't need a hard drive. It's not going to have any kind of fancy things like that. It's stored on ROM because these devices don't tend to be upgraded in any way, shape, or form. The software is very simple, so it doesn't need bug fixes or security updates or anything along those lines. It still will have RAM. So with these little devices, such as washing machines or DVD players, will have RAM to store variables as it's running. So for example, in a washing machine, when I select a program before I start my wash, it needs to remember the program I've selected. If I'm on a DVD player, it needs to know what chapter I've selected, where it is currently at the moment. So it have little variables which we'll use as it's going along, and so we'll have a very small amount of RAM. So it can be used for any device which has any form of selection. So I can select a program on a washing machine. I could have a menu system, say on a DVD, but it's not what we use on smartphones. So a distributed operating system is where we have lots of different computers all connected together via a network. Each of those computers will then have a very simple operating system or kernel, called a microkernel. And that microkernel will allow us to network, it will allow basic device management, so keyboard, mouse kind of stuff, and it will also allow basic memory access, so it can access the memory of that computer. Then all the other services of the operating system then spread across the different computers, and it also allows us to spread processes across all the different computers. So it will effectively allow us to run things in parallel. So it's a bit like having a computer with multiple cores or multiple CPUs, but these are then spread over computers. The way they communicate together will be over a network, so there is an inherent slowdown by using distributed operating system. So what can be used for? Allows us to group multiple computer devices to act as a single logical computer, ergo allowing us to do anything that's paralleled. And because we can run a process on any device, we can spread the load out and ultimately improve performance. It's not the same as a parallel architecture, so it's not the same as having a single computer with multiple CPUs in, although it can act in a similar way. The key difference show on this slide is that all those devices are connected together via a network. So in a normal parallel computer, there is one PC. In this case, each PC is connected to the network, and then the distributed operating system will then manage the problems and processes and data in such a way that they're spread out. So for example, let's say I've got a single problem and I want to split that problem up to over the different PCs. So I might send one bit of data to one bit of data to another, like that, and then maybe more data to another one, and then finally maybe the answer gets sent to a fourth computer, which then kind of sums it all up and outputs the final answer. So effectively we can have lots of different PCs all working together to solve a single. Multitasking operating systems are very common, and this is where it allows processors to schedule processes so they feel like they're running in parallel. So if I have a single CPU and a single core and I have 5 processes running at the same time, then it will swap between them very quickly in order to look like they're all running at the same time. So we can use it in any situation where we have multiple processes running. So basically anywhere we'd use a scheduler, and obviously we can use it with multiple cores as well. It's not necessarily the same as parallel processing because we're effectively kind of simulating parallel through a single core of a CPU. Multi-user. This is where we have multiple users using the system at the same time. Now, there's 2 scenarios where we could have this. So it could be where I have a single powerful computer where we all kind of log onto and use at the same time. So we use maybe what's known as a thin client or web app, for example, and then we can all use the same computer. So one example of that might be to use an app over the internet. So if you've ever used I'm talking bollocks. Let's try again.